Hi, everyone. Thank you so much for coming to my talk today. It's a great pleasure to be opening the deep learning session in today's data science conference track. My name is Petar Velickovic. I'm a staff research scientist at Google DeepMind and an affiliated lecturer at the University of Cambridge. And today I will be talking to you about one of arguably, if not the most fun projects that I've had a chance to embark on during my tenure at DeepMind, and also one which taught me a lot about designing artificial intelligence systems in potentially challenging environments. So when the data science conference team reached out to me to present here, this is my third year in a row that I'm presenting here, first time in person. I felt like it would be a really good idea if I could use this chance. I've never taken the stage in Belgrade before to talk about this specific work. The problem is the work was under embargo at the time, and I actually pushed my collaborators to get this work out as soon as possible so I would be able to talk to you about it today. And as you can see from the title, it's about designing artificial intelligence assistants for football tactics. And hopefully during this talk, you will see how using my knowledge and expertise in artificial intelligence, me and my collaborators have been able to get ourselves to this point, where basically we were able to have a very deep collaboration with a top-tier football club and use our insights to hopefully drive the next generation of their decision-making. So maybe it's a good point to start by talking about what do we mean when we say AI for football. So you've probably know about, or you're probably reasonably familiar with what a typical football coach has to do. So it is a person or a collection of people usually that have to analyze various tactical aspects of the football game and try to drive concrete and actionable decisions for the team to have better performances against their future opponents. So what do we mean when we then substitute this by an artificial intelligence? Well, we don't really substitute it, we hope to amplify it. And specifically, an AI football tactics assistant is basically a system that is capable of figuring out similar kinds of patterns and driving similar kinds of decisions, while making advantage of the vast amount of data that one might have from a football game, such as player tracking data, video data, audio data, as well as transcripts from commentary. So maybe it's worth to just start by asking ourselves, why should we deploy AI in this particular domain? And I think there's lots of good reasons why AI can amplify the human assistant coach. And that is because football is a really dynamic and challenging game to analyze. And the outcomes often depend on a lot of things you cannot easily see, like human psychology, the current weather, fatigue, injuries. And the dependence from these variables to the outcomes is quite complex. And even for experts, it's really tricky to detect all the possible interesting patterns that are taking place, and especially then tracking them across 22 different players. It's not easy for the human mind to follow all of these things simultaneously. And that's why, as artificial intelligence has shown time and time again, that it's a pretty good tool for analyzing vast quantities of unstructured data with various sources of noise. It is likely to be a natural assistant in this endeavor of ours. But also you might be asking the opposite direction. Why might it be good to use football as an area to develop artificial intelligence? I actually believe that the support goes both ways. Because football really offers us a safe and controllable test bed featuring many things we like to see when testing out artificial intelligence systems. It has interpretable outcomes with multimodal representations, and it's a real-world task with multi-agent human interactions. Lots of things we really want to see when we're developing AI systems. And also, it's a really rich domain for many disciplines of AI to come together. Areas like computer vision, game theory, statistical learning, and so on. And usually, there's a very clear metric to measure progress. How many goals did you score, for example? So with that in mind, hopefully this sets the stage for the kinds of things we want to explore. Let me start by giving you a brief journey of our multi-year collaboration with Google DeepMind that we've had with Liverpool Football Club. So our story starts around 2019, and throughout 2019 and 2020, the initial team of DeepMinders collaborated with Liverpool's senior data science teams, and they ended up publishing together this very first paper, Game Plan, which is a bit of a survey paper, which has lots of motivating examples, along with some data analyses on aspects of football like penalty kicks. And basically, it's really just trying to answer, why should AI be a good idea for assisting football tactics? Now, driving from the success of this first paper, which has been published in JAR in 2021, we have then went on throughout all of 2021 to share some of our insights with the broader community. We have organized a workshop on sports AI at IJCAI, which is one of the premier machine learning conferences. Some of the authors have even written a book on AI for sports. And also, if you haven't listened to DeepMind, the podcast before, I highly recommend it. It's a really nice listen for your morning run or otherwise, with Hannah Fry, who is an excellent science communicator. And there is actually an episode 7 in season 2, which is dedicated entirely to our football AI work. So if you're interested, this can be also a really cool resource to learn more. And now in 2022, which is around the time when I joined the project, one paper also came out, which was one of the first concrete instances of how can AI be used in analyzing football tactics. So Game Plan was a bit of a set of motivating examples and a bit of a survey, whereas Graph Imputer, which was our follow-up paper, was a concrete prototype of a system that could automate some aspect of football decision-making. And Graph Imputer, I won't have a lot of time to dive into depths about the aspects of Graph Imputer, but the main task that the Graph Imputer paper tries to answer is predicting the movements of players off camera. Now, why is this really important? Here you can see the camera region that the camera is looking at, and Graph Imputer can then predict where all the other players are going to move. This is really important because, for example, if you're a scout, you want to find good new up-and-coming players that you can buy at a bargain and then develop them into world-class players, which Liverpool has done time and time again. Basically, you want to be able to use scouts to look at players, what they're doing in various games and evaluate them. But the problem is not all leagues will offer you complete tracking data to track all players at all times. And you have a choice either to send a scout to some remote part of the world to watch the game in person, or they have to watch videos on YouTube. But the camera does not look at the entire pitch at all times, so you cannot tell where all the players are moving. Graph Imputer showed that we can reasonably accurately, by just looking at the parts of the pitch where the camera is facing, we can sort of predict where the other players are roughly going to move, and this can be quite useful to save a lot of resources of scouts' time. And driven by the success of Graph Imputer, which was really just one system showing that we can learn this, and it was published in Scientific Reports, which is one of the Nature journals, we have now written up a paper on an entire system that can not only solve various predictive tasks revolving around football analytics, but also drive decision-making and make concrete suggestions to the coaches. So TacticAI, a system developed in collaboration with Liverpool, is a system that's capable not only of answering what will happen, which is a predictive model, it's also capable of analyzing what happened after the fact, so supporting various embeddings and retrieval systems, and also what do I need to change in a situation to make a particular outcome happen? So how should I move my players to make a goal more likely or less likely? These kinds of situations were not answerable by previous systems, and TacticAI supports all of them together. So TacticAI, this is the first takeaway message. It's a full AI system. Graph Imputer was just a single prototype of a decision-making system. TacticAI is a full AI system giving useful tactical suggestions to coaches. And while this might sound like a bit of a bombastic and unprovable claim, I will prove it to you because we've done a case study with Liverpool team experts to analyze that these suggestions were indeed being useful. Now, how can we actually build a system like this? Let's pause for a second and ponder the aspect of usefulness. Football, as you might know, is a very dynamic and hard to influence sport. There's lots of things happening at all times, and sometimes if a coach decides to shout at their players, that might distract them rather than work towards a particular objective. So actually making suggestions that influence a game of football and analyze it on the fly is quite hard. We did not really want to look at this for building a useful system. Luckily for us, football is full of these frozen situations known as set pieces, such as corner kicks, where the game is effectively frozen. And this now offers us a bit more of a tactical advantage and the situation where we can actually make actionable suggestions to the coaches because there's a lot less dynamic happening before a corner kick than during free play. And also, I hope some of you in the audience have seen Moneyball or read Moneyball. I think this is partly the reason why Moneyball worked as well as it did. In baseball, virtually every single step of the game is a set piece. So the game is always frozen in between steps, which means that you can actually do advanced statistics to decide in what order you're going to arrange your players. So hopefully you agree with me that set pieces are a good place to look. In football, we have 4 different types of set pieces: penalties, throw-ins, free kicks, corner kicks. The original game plan paper actually already studied penalties in great depth. And if you look at these 4, it's actually quite obvious which one we should focus on. It is really corner kicks, because they tick all the boxes for something that we can influence, and influence in a meaningful and consistent way. Because corners are frequent, they happen quite often in every single football game. They are rigid, they always take place from the same position on the pitch, which is the corner, and they allow for immediate goal scoring. Very often a corner could lead to an imminent opportunity for a shot at goal. And also, this we learned through our discussions with Liverpool, they don't just let the players decide randomly at every point in time how to take the corner. They decide the corner strategies up front well before the game takes place. So this now gives us a lot of opportunities for an immediately useful system. Let's focus on corner kicks. They seem to be really the right thing to look at. Now, how did we build a system that analyzes corner kicks? Well, the key architecture that we are using inside this system is the graph neural network. It's basically hoping and trying to map the different synergies between the players in a graph structure. And this is where my expertise comes in, because for those of you who know my work, I've been involved in graph representation learning for many, many years back. You might be familiar with some of the works I've done towards this. I was part of a team at DeepMind that developed the travel time prediction system in Google Maps, which is now deployed worldwide. So even in Belgium, if you ask Google Maps, I want to travel from A to B, the travel time estimate that is served to you is driven by a graph neural network system that we have developed. I was part of this team. And I was also part of a scientific research team that used these graph neural networks to help mathematicians detect hidden structures inside really complicated objects, which then led to those mathematicians solving 50-year-old challenges that have been virtually untackled in the past decades. And this led us to the cover of Nature, which is the most prestigious journal for science. So this is something that I really, really enjoy doing. I really enjoy modeling the relational structure of the world. And in football, arguably, that is quite omnipresent. Like, different players have different synergies. They like to play more or less with each other and do different tactics together. So a graph is really a natural structure to model the player interactions. Now, how do we do this? So whenever I show you a picture of a pitch, here I've deliberately just taken a set of 6 players to make it easier to visualize. So we have a pitch with 6 players. We have some tracking information on them. We extract them to be nodes in a graph. And inside these nodes, we can encode various features like player positions, team allegiance, coordinates, and so on. And once we have a graph structure like this, then we can use the graph neural network to simulate various steps of message passing between those features to learn a latent space representation from which we can then predict various things about the football game. So there's various features you can put in these graphs. For example, where are the home and away goalposts, player positions, velocities, heights, weights, ball possession, and so on. And then you can formulate various interesting tasks as tasks on a graph. So whether or not the shot took place, that's a graph classification problem. Is there like who receives the ball? That's a node classification problem, and so on and so forth. Now, one big challenge that we have in football, which we don't often have in big deep learning applications, is we don't really have a lot of gold standard data. A club typically plays only about 100 games every season, or even less. So there's not a lot of corner kick situations we can use to train our system. We use data from the Premier League specifically. So the way we fix this problem is by using a technique known as geometric deep learning, which automatically exploits interesting symmetries of the football pitch. So what this means is, let's say we have a corner kick situation, such as this one. A geometric deep learning system will then generate 4 different reflections, horizontal and vertical, of the pitch, which for our intents and purposes, we consider to be identical situations, and we want the model to process them identically. So we then feed these 4 situations together into TacticAI, the graph neural network system, which then predicts representations for every single view and aggregates them. And then based on this aggregate view, remember, the view is aggregated to ensure we'll get the same responses for all 4 views, and therefore encoding the fact that the system should behave the same under reflections. We can then predict who makes first contact with the ball, receiver prediction. We can predict, will a shot be taken, which is shot prediction. And we can also adjust player positions to increase or decrease the shot probability. Those are the 3 tasks that we look at specifically. And all those tasks come together in the final one, which is the guided generation. So let me just show you how TacticAI does it. Let's consider this particular corner kick where a shot by the red team has happened. We can ask TacticAI to predict adjustments for the blue team such that the probability of a shot is reduced. And indeed, TacticAI obliges. Here I've highlighted the most salient changes it proposes. So you can see for some of the blue players, it predicts a change in position, a change in orientation. So it's a bit more blocking, they're a bit more covering, and generally reducing shot probability significantly. And actually, this also has an effect on the prediction of who receives the ball. Attacker 1, who is an attacker who is far away, now has a much higher shot probability than before, whereas the attackers in the box have a lower shot probability. So these suggestions actually make it less likely that the red team will successfully kick the ball into the box. Now, I have to, because this is a machine learning paper, first and foremost, I have to start by giving you a few quantitative numbers as to how good these predictive systems are. Although very quickly, I will tell you to forget all about them, don't worry. So, receiver prediction, predicting who is the first player to receive the ball. We have about 78.2% top 3 accuracy. So out of the top 3 predictions of TacticAI, about 78% of the time, it predicts the correct player. Shot prediction, much harder thing to predict. We have an F1 score of about 0.64. And when we do guided generation, so changing the player positions either to increase or decrease shot probability, we find that with a very low p-value, we are able to decrease shot probabilities when we move the defensive team, and we're able to increase shot probabilities when we move the attacking team. And also, very importantly, the generations TacticAI proposes do not seem to be weird or unusual because we cannot, they're indistinguishable from real corners by an MLP classifier. So a classifier is unable to tell whether a corner is real or it came from TacticAI. Now, please forget about all these numbers. This was just very important for me to say, as a machine learner, that it's very important to report these metrics. But what we really care about, as I said, is building a useful system. And while quantitative metrics are useful for evaluating machine learning systems, they tell you nothing about how humans will make advantage of these systems. So in the context of football, whether or not a pass or shot happen can depend on many factors that our model never sees, such as human psychology or fatigue. So to truly evaluate how useful our system is, we put it to the test with human expert case study. We took 5 expert raters from Liverpool Football Club, video analysts, coaching assistants, goalkeeper assistants, and data scientists. We showed them over 300 different corner kicks, both real and TacticAI generated, to support one of the largest scale football human case studies that have taken place so far in machine learning. And all the results that follow will be calculated from these expert human ratings. These are the ratings you should remember. So first, can humans tell apart TacticAI generations from real corners? They cannot. They assign roughly the same realism ratings to both real and generated corners with a very high p-value. And the receiver predictions by humans is about 79%, which is exactly the same receiver prediction that TacticAI has. And this accuracy is roughly the same both for real and for generated corners. So TacticAI still generates viable receiver predictions around at the same level as the human experts. So, what's the takeaway from this? Experts cannot distinguish TacticAI adjustments from real corners, and experts predict corner kick receivers equally well as TacticAI. That's the first important step to the validity of our predictive models. Now, TacticAI embeds players in a high-dimensional space, and maybe we can exploit that space to retrieve similar corners. One very common thing that human coaches have to do when they're facing a new team is to retrieve what are the most common corner kick strategies that this team does so they can prepare better for it. So retrieval is a very useful task for them. And as you might expect, points that cluster together in the representation space tend to be corners with really similar patterns. This is something we detected by manual inspection. So 2 corners that TacticAI embedded very closely together have really similar representations. And as you might expect, 2 corners that are far away can have very differing tactical advantages, like in-swing versus out-swing corners, which are considered to be completely different tactically. So then we wanted to validate, could this system be used as a retrieval system? So first we checked how well can we mine corners using just raw feature similarity. So 2 corners with closest player positions. We showed those pairs to humans. They found this useful about 33% of the time. Then we showed them corners retrieved based on TacticAI embeddings, and they found that useful 63% of the time. So clearly, TacticAI finds something that is not present in raw features alone, and the average rating assigned to retrievals is significantly higher with a very low p-value, and also there's a very high inter-rater agreement. So not only do humans on average prefer TacticAI, humans agree that TacticAI is better. So it's not just on average, it's high agreement. So experts prefer TacticAI-based retrievals to raw feature ones, and experts have a high degree of agreement over these ratings. So it's not just that we found a good average number, all individual numbers are really good. And lastly, my favorite part, we use TacticAI to generate possible adjustments to tactics for the defending team. And we asked our raters from Liverpool to rate whether TacticAI improves the situation, makes it worse, or no significant difference. By the way, we didn't tell them which situation was real and which situation was TacticAI generated. So this was always randomized to make them less biased. And we assign a rating of +1 if it makes it better, -1 if it makes it worse, 0 if there's no difference. So our average rating is between -1 and +1. Our average rating is 0.7. So humans on average prefer TacticAI suggestions significantly more. And actually, if you look at concrete situations, on 90% of the corners we showed them, the average majority rating by voting was positive. So humans generally really prefer the corner kick suggestions from TacticAI. And remember, we showed you before, they cannot tell them apart from real ones. And inter-rater agreement, again, super, super high. So humans generally all say the same ratings on TacticAI corners. It's not just we took an average and it turns out to be good. Each individual rater gave a high rating to TacticAI. So key takeaway and my favorite takeaway. Experts prefer TacticAI suggestions over existing tactics 90% of the time. And experts have a high degree of agreement over their ratings, which hopefully shows to you that we've actually built a useful system. And I found it useful to also show you some of TacticAI's greatest hits. So these are some of the corner kick situations where humans particularly found the suggestions useful. You can see the highlighted players in orange. Those are the ones where the humans were really happy about the adjustments. You can see they're all making much better covering runs of the opponents. Then you can see another situation. Once again, here you have players that are generally very stationary on the left-hand side, but TacticAI gets them more moving and more eager to intercept. Similarly, in this situation, you have two players moving in a completely weird direction. TacticAI course corrects and tells them which way they should go. And another one where you have players trying to block, but with very low velocity. TacticAI agrees it's probably better for them to make covering runs than to block. And all of our coaches in the case study agreed with this. So, in conclusion, we studied a dynamic set of problems around inferring corner kick dynamics. This was powered by graph neural networks and geometric deep learning, leading to increased data efficiency. And our model is both a predictive model and a generative model. It produces realistic and quantifiable adjustments, which humans find useful. And LFC experts, specifically through our case study, found these to be significantly useful in a domain where we can make actionable choices, actually. So it's not live human play, it's within corner kicks, which you can make far more influence on. And in short, I would say, and I hope you agree with me, we now have an AI assistant for football tactics on our hands. Now, before I conclude the presentation, I want to make an important announcement. I said, for those of you following me on Twitter or LinkedIn, you've seen I'll make an announcement about AI in Serbia. So, EML 2024, the greatest, the best machine learning summer school for the Eastern Europe region, is coming to Serbia. After 3 years of trying to convince the organizers to make it happen, this great summer school sponsored by Google DeepMind is coming to Novi Sad at the AI Institute. And it's very conveniently sandwiched between Exit Festival and ICML. So if you prefer research, if you prefer music, you can connect it with either of those two things. We already have fantastic speakers. Take a look at some of our speakers. Many of them are top-tier professors from Oxford and Cambridge. Many of them top scientists at Google DeepMind and other companies. And we have many more to come. These are just the people who have, in the first wave, confirmed they're coming to Serbia to give us talks on top-tier topics in AI research. We also have excellent tutorial hosts, both from DeepMind, Mila, and Microsoft Research, as well as University of Belgrade, some local representation. And if any of this sounds interesting, we open applications in January 2024. It is an Eastern European summer school, but it's open to all. And applications will go on until March. If it sounds interesting, check out eml.eu for all details. And we hope to see you there in Novi Sad in July. Thank you so much. Hope you enjoyed it.
Yeah.
Right. I mean, this was my concern to begin with as well. We raised it with Liverpool, and they basically said this might have been a problem in the 1950s or 1960s, but in modern football, all top-tier players are trained to work on both sides, so they consider these situations to be nearly equivalent. So the Liverpool people said this was okay.
Somebody else? Yeah?
I think there's a question. Well, I mean, here we have one particular instance of a system that looks only at tracking data and makes actionable choices. I think to go beyond, we can go fully multimodal. So incorporate all of these other streams of data that are very common in football analytics, like video data, transcript data, and so on. I feel like this can give extra context to a model like this and make it truly more powerful, maybe with less data required. I imagine that will be the next frontier, and hopefully maybe even drive decision-making on more complex things like game formation and things like this. Yeah.
Yes.
There was a question there?
Regarding the part, regarding the part of the system that suggests interventions, how do you handle, since that problem is inherently causal, right? Mm-hmm. And you don't have counterfactuals in the data. And how do you handle the modeling of the system? And more importantly, how do you handle the evaluation, especially the metrics that you report on how it would turn out if you accepted the suggestion?
Right, that's a great question. So this was obviously done in great consultation with Liverpool, who would actually hopefully be using this system. What they basically say is that corner kick strategies are decided up front for the attacking team, and then the defending team needs to move in response to this, right? So you could use this as an actual counterfactual to like change your responses on the fly, but what it actually will help coaches with a lot more is to identify, very clearly pinpoint which players are not doing their job right, like which players are being lazy. So really it can help coaches do the thing they were doing all along, but just help them zone in on where to look, rather than actually execute the entire counterfactual. Though it would be... Sorry? I mean, we used human data metrics. Do humans see this as a useful suggestion, yes or no? And the average is really high, so.
Yes.
Mm-hmm. Mm-hmm. No. No, so it was two of the people in the evaluation are also our co-authors on the paper, but the study was kept completely blind to them. They had no idea what we were about to ask them, and they didn't really have a feeling for how the system works before we showed them these situations. So. I mean, they did supply original ground truth data, and one of them, actually, the corner kick analysts, tried to actually retrieve, like, is this a corner I've seen before or not, to gauge whether it's real or fake. That person also couldn't tell real corners from fake. So, like, it's like the generations were generally convincing. Yeah.
Somebody else? Yes.
Do you take into account physical or technical attributes of the players that are participating in the attacking or defensive actions?
Great question. So we basically deliberately put a very rudimentary set of features like height, weight, playing position, or foot, or something like this. We don't focus on more elaborate player statistics, because the idea is we want to show already with a minimal set of features you can make something useful, and then clubs like Liverpool can then put in their own proprietary data and kind of supplement the system with any extra tactical information that they might have or compute. So we deliberately do not do this to show that the system is useful already on a minimal set of features. Yeah.
My question is, this is for offensive tactics or for defensive tactics?
So the evaluation was primarily done on defensive tactics, because our collaborators told us this is how the system is most likely to be used, because the attacking team chooses the strategy, and then the defensive team is the one that needs to respond to this strategy. So you'll have more salient kind of interventions on the defending team. Although we did also evaluate, as we saw in the quantitative metrics, can we move the attacking team to increase shot probability? And generally the answer is yes. So.
Okay. And second question is, who were the early adopters of your, how to say, introduction of the product? Coaches, maybe general manager, or other stuff in the...
So the earliest users of the technology were our direct collaborators, the data science team at Liverpool, so people who actually do the data analytics. But with this new class of systems, we expect this to help assistant coaches, goalkeeper coaches, across the board. They can make advantage of the suggestions coming out of the system. We had them in our case study. We had coach assistants and other people as well.
My question is, you showed an example of 2 corners in your presentations. Can you explain something that the experts from Liverpool told you? What is the suggestion from TacticAI that improved the situations for the defending team?
Yeah, so
on the example, yeah.
I tried to I had to speed run it. I didn't have a lot of minutes left, but I sort of said very quickly what were the most salient players. Basically, they were either moving in a completely off direction, so did not match what they were supposed to be doing, or they were trying to block the player with a very weak run when the player was running very quickly with high momentum. So the system basically decided when to correct. Like if it seems this strategy will not work, suggest the player to actually follow rather than try to block or try to move more closely. With goalkeepers, we had a goalkeeper coach on our evaluation team. He often looked at the goalkeeper, like, is this goalkeeper better positioned or worse? And there were many situations where he said, I'm quite sure this corner is fake. Nobody would put their goalkeeper this far ahead. And actually, that was the real corner. So, yeah, there's all sorts of suggestions across the board in these systems that they found useful.
Somebody else? Yeah?
No, so short corners are part of our data set and part of the receiver predictions. So, TacticAI has to also predict if there's a chance of a short corner. And in those cases, we can make appropriate defensive adjustments if a short corner seems most likely. So, they are part of the analysis. All of the aggregates contain short corners as well. Mm-hmm. Right. So I think the shot prediction is quite long horizon. Like it looks at until the ball kind of leaves that entire box area. So if there was a shot event, it will be part of the shot predictor. So it takes into account crosses, follow-ups, and things like that. Yeah.
Yes?
So at this particular time, we are not planning on pursuing anything commercially with this work. Liverpool might make advantage of this because obviously they gave us their data and we did a long-term collaboration with them. But the information of the system is now public. The data that we used, most of it can be collected from standard data providers. So I would not find it hard for another club to potentially use these insights and develop a system of their own based on what we did.
Yes?
Regarding one last question, regarding the cooperation with the coaches, because the older coaches, they prefer the eye test over analytics. How do you find their cooperation with you? Did they basically approach it with an open mind, or they were a bit skeptical regarding if the AI can really replace the knowledge of a coach? So yeah.
Right. So basically, our general feeling at the start of the collaboration was that the closer they were to data analytics, so data scientists, they were the most trustworthy that this would work. Whereas more closer to actual player coaches, they were less convinced at the beginning. But then they saw some of the predictions coming out of the system, and they analyzed the predictions coming out of the system. They told us, these are their words, they are definitely certain that outputs from a system like this could help them speed up their day-to-day job. We don't think this will replace humans. Nobody really thinks this will replace humans because a human still has to understand the human nature and how to best act on a player based on the outcomes of a system like this, like how to motivate them to actually do better in the future. So I don't think the coach's job is going away anytime, but I do think coaches are about to progress at digital speed. So.
Thank you very much. This is a certificate of appreciation of us.
Mm-hmm.
Thank you.
Thank you so much. Thank you all.